In this third section of thermochemistry, we're going to talk about enthalpy changes and phase changes. So let's go ahead and get started. In order to break intermolecular bonds, a certain amount of energy is required, and this has been recorded by experimental data. These values you see here in this table all deal with water, and they will be given to you in almost every single problem you do. And if you have any trouble figuring out where the numbers came from, please refer back to this part of the video to see these numbers. So the molar heat of fusion is positive 6.0 kilojoules per mole, and that means that to melt water it takes 6.0 kilojoules for every mole of water we do. Molar heat of vaporization, or the boiling of water, takes about 40.7 kilojoules per mole. And then we have our specific heat of ice, specific heat of water, and specific heat of steam. So notice that each phase of water requires a different enthalpy value. So here's our sample problem that we want to do. How much energy is needed to convert 180 grams of ice at negative 12 degrees Celsius to liquid water at 25 degrees Celsius? Well, in order to do this, we have to take our ice and raise the temperature. In that case, we're going to use the MC delta T equation because the temperature is actually changing. But once we get to the 0 degrees Celsius where the ice is melting into water, we have to use the delta H of fusion. But once all of that ice is melted into water, the temperature will begin to change again, and we'll go back to using the MC delta T equation. So let's see what we got. From negative 12 to 0 degrees Celsius, we are raising the temperature of ice. So we used Q equals MC delta T, where the mass is 180 grams, the specific heat of ice is 2.09 joules per gram dot degrees Celsius, and our change in temperature is 12 degrees Celsius, giving us a total amount of heat needed to raise that temperature of 4,514 joules. Let's look at the melting of ice because we're now at 0 degrees Celsius. So to melt the ice, we use the heat of fusion. Now the heat of fusion is equal to 6.0 kilojoules per mole. We're going to multiply that by the number of moles of water, or in this case, really ice. So how did I get that 10 moles of ice? Well, we had 180 grams of ice, and we divide by its molar mass of 18 to get 10 moles. That gives us 60 kilojoules of heat necessary to melt that much ice. I've gone ahead and converted that into joules, which is 60,000 joules. Now that all of our ice is melted, we can actually take the 0 degrees Celsius water and raise the temperature up to 25 degrees Celsius. Well, we're changing the temperature again, so we're going to use Q equals MC delta T. The Q is equal to 180 grams of water times the specific heat of water times the total change in temperature, which is 25 degrees Celsius. That'll give us 18,810 joules. If we take all three of these heat values and add them together, it should give us the total amount of joules necessary to raise ice from negative 12 degrees Celsius to 25 degrees Celsius of water. We add those together, we end up getting 83,324 joules, which is equivalent to around 83 kilojoules of heat necessary.